I think that at the bottom of the barrel, what people are really worried about is that if we have an entirely naturalistic and ultimately, in a certain sense, mechanistic at the nano level, at the protein level, if we have a mechanistic theory of consciousness, this will show that, oh my gosh, we don't have free will, and then life has no meaning, and I can't be responsible for my best or worst deeds. And that doesn't follow. But fear that it would follow rattles people and deflects them from taking these ideas seriously because they really don't want them to be true. My approach to that is to challenge that desire and say, no, everything you want or should want in the way of free will, you can have on this picture. There's some traditional notions of free will that turn out to be impossible on this view. Tough. But why do you want them? They're not important. They are simply ill-founded desires. The varieties of free will worth wanting, you can have. And so take a deep breath, relax, and let's figure out how it's done.
Dan Dennett has often said that, and this is something that, at a phenomenological level, like if you just attend introspectively to what's going on, that often it's not like a decision is an event. It's like you're sort of waiting for the decision to bubble up, right? You think, well, what should I really do here? Well, I'll go sleep on it, and you wake up, it's there. You know what to do. So the thought is, at this point, that it may be that we need to really kind of rethink the whole structure of what goes into decision-making and choice and so forth. And part of what I'm going to suggest a little bit later is that the notion of self-control might actually serve us better in this context than the notion of free will. Because free will seems to suggest, for example, that either you have it or you don't. Whereas we know self-control comes in degrees and can vary as a function of all kinds of things, including developmental stages, hormones, brain damage, and so on. And then I think it will be easier too, if we have that kind of a framework, to begin to think about the neurobiology of self-control and how it is possible for something to have dysfunctional self-control. And we'll talk a bit about that in the context of frontal damaged patients. But more importantly, how is it that we can defer gratification? What's the circuitry for that? I know how folk psychology invites me to think of that. That I have a strong will and that sometimes my will is weak. But that can't be right. And one thought, and Guy Claxton has, as I think, a very interesting idea about this, is that part of what goes into developing self-control and learning to defer gratification is learning to predict what things are troublesome for you and then doing them slowly, right? So you've been punished for a certain event, you're tempted by it. If you do it slowly, it allows time for the brain to construct other scenarios, to construct mental images of the bad thing that will happen, and that allows different circuits to take over and so forth. And so it's a way, this is very preliminary obviously, but I think it is a kind of invitation to think about a research strategy that looks at the will in quite different ways. So one way to think about the nature of the free will problem has to do, in fact, with understanding the causality that underlies self-control. Now, we know that self-control can be undermined not just by things like extreme hunger and extreme exhaustion. It can be undermined by drugs. So a huge effort around the world has gone into understanding the neurobiology of addiction. And the main addictive chemicals that people have studied involve cocaine, heroin, nicotine, and alcohol. And what is known now is that, I mean, it's going to be a very complex story, and I think only part of the story is in place. But we know that there are very specific physical changes in the reward system in the basal ganglia. And it sometimes looks as though those very specific changes actually are quite permanent. But we know, for example, that if someone is addicted to nicotine, that in certain very specific kinds of experiments, for example, when they evaluate what they could have done in a task, unrelated to smoking, but where they could have done something in a task instead of something else, they're poor at making those evaluations. And so understanding addiction is very, very closely related to understanding the nature of self-control. And here's another important part of what has come into focus in understanding addiction. And that is that initially someone will get a hedonic response. That is, you get high or you feel great from binge taking the substance, let's say cocaine. But always after the hedonic response, there's a bit of a dip, normally. But after someone takes cocaine again and again, what we see is that hedonic response is not very high. The anhedonic response is quite low, deep, and it's protracted in time. Well, what causes the anhedonic response that follows? And the answer seems to be stress hormones go way up. Now, you know what it's like to feel anxious, to feel stressed. It's uncomfortable. So what does the addict do when they're in this anhedonic trough that goes on for a long time? They take more, which gives them an even lower hedonic response and an even longer dip into the anhedonic response. And this profile, I think, has helped us really understand sort of the conscious experience of addicts, but it's also really helped us to understand the nature of addiction itself.
I don't believe there's such a thing as free will in the sense of a ghost in the machine, a spirit or soul that somehow reads the TV screen of the senses and pushes buttons and pulls levers of behavior. There's no sense that we can make of that. I think our behavior is the product of physical processes in the brain. On the other hand, when you have a brain that consists of 100 billion neurons connected by 100 trillion synapses, there is a vast amount of complexity that means that human choices will not be predictable in any simple way from the stimuli that have impinged on it beforehand. We also know that that brain is set up so that there are at least two kinds of behavior. There's what happens when I shine a light in your eye and your iris contracts, or I hit your knee with a hammer and your leg jerks upward. We also know that there's a part of the brain that does things like choose what to have for dinner, whether to order chocolate or vanilla ice cream, how to move the next chess piece, whether to pick up the paper or put it down. That is very different from your iris closing when I shine a light in your eye. That second kind of behavior, one that engages vast amounts of the brain, particularly the frontal lobes, that incorporates an enormous amount of information in the causation of the behavior, that has some mental model of the world that can predict the consequences of possible behavior and select them on the basis of those consequences. All of those things carve out the realm of behavior that we call free will.
For billions of years on this planet, there was life but no free will. Physics hasn't changed, but now we have free will. The difference is not in physics. It has nothing to do with determinism or indeterminism. It has to do with, ultimately, with biology, particularly evolutionary biology. What has happened over those billions of years is that greater and greater competences have been designed and have evolved. And the competence of a dolphin or of a chimpanzee, the cognitive competence, the sort of mental competence, is hugely superior to the competence of, a lobster or a starfish. But ours dwarfs the competence of a dolphin or a chimpanzee, perhaps even greater extent. And there's an entirely naturalistic story to tell about how we came to have that competence or those competences. And it's that can-do, it's that power that we have, which is natural, but it's that power which sets us aside from every other species. And the key to it is that we don't just act for reasons, we represent our reasons to ourselves and to others. The business of asking somebody, why did you do that? And the person being able to answer it's a very simple and it's an everyday phenomenon, but it is the key. And it is the key to responsibility. And in fact, the word responsibility sort of wears its meaning on its sleeve. We are responsible because we can respond to challenges to our reasons. Why? Because we don't just act for reasons, we act for reasons that we consciously represent to ourselves. And this is what gives us the power and the obligation to think ahead, to anticipate, to see the consequences of our action, to be able to evaluate those consequences in the light of what other people tell us, to share our wisdom with each other. No other species can do anything like it. And it's because we can share our wisdom that we have a special responsibility. It's, as the old tag would have it, it's noblesse oblige. We have the power, and that's what gives us the obligation. And that's what makes us free in a way that no bird is free.